Hi, Professor Jones. I'm really struggling with the final project for our environmental science class. I've chosen deforestation as my topic, but I'm having a hard time organizing my ideas.
I understand. Deforestation is a broad and complex issue. Have you considered breaking it down into smaller, more manageable parts?
I thought about focusing on the impact of deforestation on biodiversity, but I'm not sure if that's too narrow.
That's actually a very good approach. Biodiversity is a critical aspect of deforestation, and narrowing your focus will make your project more detailed and impactful. You can explore how the loss of trees affects various ecosystems and species.
That makes sense. Should I include case studies from specific countries or regions?
Yes, definitely. Case studies will provide real-world examples that support your analysis. For instance, you could look at the Amazon rainforest in Brazil and how deforestation there has affected not just biodiversity, but also indigenous communities.
Oh, I didn't think about including indigenous communities. That could add an important social dimension to my project.
Absolutely. Deforestation affects both the environment and the people who live there. You could even touch on efforts to prevent deforestation, like reforestation projects or sustainable agriculture initiatives.
Thanks for the advice. I feel much more confident now.
Hey Mark, I wanted to ask you about your presentation on renewable energy. How did you come up with the idea to focus on solar power?
Oh, that was easy. I've always been interested in clean energy, and solar power seemed like a topic with a lot of potential. There's so much going on with new technologies, from solar panels to solar farms.
That's true. But don't you think it's a little too common? I feel like everyone talks about solar power.
I get what you're saying, but I think it's important to highlight how solar technology is evolving. For example, I included a section on solar cells made from perovskite, which could make solar panels cheaper and more efficient.
That's really cool. I hadn't heard of perovskite before. How did you find that information?
I did a lot of reading on scientific journals. There's a lot of research going into making solar cells more efficient. Plus, I talked about how solar energy storage is improving with new battery technology.
That makes sense. I'm focusing on wind energy for my project, but now I'm wondering if I should include a section on energy storage too.
You definitely should. Energy storage is key for renewable energy to become more reliable. Otherwise, when the sun isn't shining or the wind isn't blowing, the grid can't rely on these sources alone.
Great point. Thanks, Mark. I'll take a look at that.
Hi, Professor. I wanted to talk to you about my research proposal on social media's influence on teenagers' mental health. I'm worried it might be too general.
It's a very relevant topic, but you're right. It can be broad. Have you thought about narrowing it down to specific platforms, like Instagram or TikTok?
I was actually thinking of focusing on TikTok. I feel like it has a unique culture that affects teens differently from other platforms.
That's a great idea. You could explore how the constant stream of short videos impacts attention spans or self-esteem, for instance.
Exactly. And I was also planning to look into how certain challenges or trends can influence body image issues.
That's definitely a significant concern. I would suggest looking at some recent studies that explore these issues. You might find data on how teenagers perceive themselves after participating in TikTok trends.
That's helpful. Do you think I should include interviews with teenagers in my research?
If you have the time and resources, that could add a valuable personal perspective. Just make sure your sample is diverse in terms of gender, age, and social background.
Thanks, Professor. I'll get started on refining my proposal.
Hi, Sarah. I heard you're working on a research project about urban planning. How's it going?
Oh, it's going well, but it's a lot of work. I'm focusing on how cities can be made more sustainable.
That sounds interesting. Are you looking into green spaces and public transport?
Yes, both of those are key components. But I'm also looking at waste management and energy-efficient buildings. One part of my research is on smart cities that use technology to reduce energy consumption.
Smart cities? That sounds high-tech. How does that work exactly?
Well, smart cities use sensors to monitor traffic, energy usage, and even air quality. These sensors help cities become more efficient by managing resources better. For example, if there's a traffic jam, the system can reroute cars to reduce congestion and save fuel.
That's really cool. Are there any smart cities in the world right now?
Yes, a few places are implementing these technologies. Barcelona and Singapore are great examples. They've both incorporated smart city technologies to manage energy and reduce pollution.
That's amazing. I didn't realize cities were becoming so advanced. Do you think this is the future for most cities?
I think so. As populations grow, we'll need cities to be more sustainable and efficient.
Today we're going to discuss the role of enzymes in biological systems. Enzymes are proteins that act as catalysts to speed up chemical reactions in cells. Without enzymes, many reactions would occur too slowly to sustain life. One key thing to understand is that enzymes are highly specific. Each enzyme only catalyzes one particular reaction. This specificity is due to the enzyme's active site, which is uniquely shaped to bind to a specific substrate. When the substrate fits into the active site, it forms what's known as an enzyme-substrate complex, and the reaction proceeds. For example, in your body, the enzyme amylase breaks down starches into sugars. But amylase won't break down proteins. That's the job of enzymes like pepsin and trypsin. Enzyme activity can be affected by various factors, including temperature, pH, and substrate concentration. Most enzymes have an optimal temperature and pH at which they function best. For example, human enzymes typically work best at body temperature, around 37 degrees Celsius. Now, one interesting thing about enzymes is that they can be regulated. This means that the cell can turn enzyme activity on or off, depending on the cell's needs. One way this happens is through inhibitors, which are molecules that decrease enzyme activity. There are two types of inhibitors: competitive and non-competitive. Competitive inhibitors bind to the enzyme's active site, blocking the substrate, while non-competitive inhibitors bind elsewhere on the enzyme, changing its shape so that it can no longer function properly. Enzymes also play a crucial role in drug development. Many medications are designed to inhibit enzymes that cause disease. For instance, the HIV drug AZT inhibits an enzyme that the virus needs to replicate.
Today, let's dive into the topic of human evolution, specifically focusing on the role of early hominins and their migration patterns. When we talk about hominins, we're referring to a group that includes modern humans, our immediate ancestors, and other extinct species that are more closely related to us than to chimpanzees. One of the key developments in human evolution is the transition from bipedalism, or walking on two legs, which appeared millions of years ago. This change allowed early hominins to free up their hands, enabling them to use tools and carry objects. Fossil evidence of Australopithecus afarensis, one of the earliest known hominins, shows clear adaptations for bipedal walking, such as changes in the structure of the pelvis and leg bones. Now, the first major migration out of Africa took place about 1.8 million years ago. Homo erectus, a more advanced species, is believed to be the first to leave the continent. Homo erectus was highly adaptable, and their ability to use tools and control fire helped them survive in a variety of environments. This migration eventually led to the spread of hominins across Europe and Asia. One fascinating aspect of early human migration is how it shaped genetic diversity. For example, Populations that migrated farther from Africa have lower genetic diversity compared to those that remained in or near the continent. This is because each group that left Africa was a smaller subset of the original population, leading to what's known as a genetic bottleneck. The study of human evolution is also supported by archaeological findings. In regions like the Middle East and Europe, we found stone tools and fossils that trace the spread of hominins. These findings give us insight into how early humans adapted to different climates and landscapes.
Our topic today is the Industrial Revolution, one of the most transformative periods in human history. It began in the late 18th century in Britain and quickly spread across Europe and the Americas. This era saw profound changes in manufacturing, transportation, and society. One of the key developments during this time was the mechanization of the textile industry. Before the Industrial Revolution, textiles were made by hand, which was time-consuming and labor-intensive. However, inventions like the spinning jenny and the power loom revolutionized the industry. These machines allowed factories to produce textiles on a much larger scale and at a faster pace. Another significant change was in transportation. The invention of the steam engine by James Watt played a crucial role. Railroads and steamships could now transport goods and people faster than ever before, linking cities and nations. This created not only an economic boom, but also spurred urbanization as people moved from rural areas to cities in search of factory jobs. However, the Industrial Revolution wasn't without its problems. While it brought economic prosperity, it also led to poor working conditions in factories, including long hours, low wages, and dangerous environments. Children were often employed, and labor laws were practically non-existent at the beginning of this era. The environmental impact was also considerable. The rise of factories led to increased pollution, especially in urban areas where coal was the primary energy source. Over time, social reform movements began to address these issues, but the Industrial Revolution remains a double-edged sword in history, symbolizing both progress and exploitation.
Today, we'll be discussing the concept of ecosystem services and why they are critical to both human well-being and the environment. Ecosystem services are the benefits that humans derive from natural ecosystems. These services can be divided into 4 categories: provisioning, regulating, supporting, and cultural. Provisioning services are the tangible products that ecosystems provide, such as food, water, timber, and medicinal plants. These are the resources that humans use directly from the environment. Regulating services include things like water filtration, carbon storage, and pollination. For example, forests play a crucial role in regulating the Earth's climate by absorbing carbon dioxide, a major greenhouse gas. Supporting services are the underlying natural processes that allow ecosystems to function. These include nutrient cycling, soil formation, and photosynthesis. Without these processes, life on Earth would not be sustainable. Finally, cultural services refer to the non-material benefits that humans obtain from ecosystems. These can include recreation, aesthetic enjoyment, and spiritual fulfillment. National parks, for instance, provide a place where people can connect with nature and relax. Unfortunately, human activities like deforestation, pollution, and overfishing are threatening many of these ecosystem services. Protecting ecosystems is not just about saving wildlife. It's about ensuring that we can continue to benefit from the services they provide.